Certain amount of sand, certain amount of water. Certain amount of sand, certain amount of water. Hi guys, today we're going to talk about conservation of mass. All right, let me pull your attention over here to our notebook. Today our learning target is I can develop a model to describe how the total number of atoms does not change in a chemical reaction. Thus, mass is conserved. So our important phrase today is law of conservation of mass. Say it with me. Law of conservation of mass. It's a law that states that that matter cannot be created nor destroyed during a chemical reaction. So later today, after you've watched a video, some examples, read some information, I'm going to expect that in this place in your notebook, you use pictures, chemical formulas, or diagrams to show how conservation of mass is true in two ways. So I want pictures and words, or pictures and letters, or a chemical equation. Okay, and I want you to include a written explanation or example of the law of conservation of mass in your own words. So let me give you a couple of examples just so that you can kind of have this in mind. Now, I'm not going to do any chemical reactions here, but I want you to kind of understand that when you put things together, one doesn't necessarily disappear or go away. New matter is not necessarily created, but it might be different. So what I have here is some water and some sand. We already covered this earlier. So what I'm going to do is I'm going to take the water, and I dyed it blue, right? Does that mean that I can't really take the food coloring out of here, it's dissolved, but I dyed it blue so that you could see it. But when I add the water to the sand, is it going to go up exactly the same amount? It really isn't, right? Because the water molecules go in between the sand molecules. So if I put water in here, you can clearly see that I'm pouring it in there, but it doesn't look like there's any water in there at all, right? So it might look like wet sand, but I have less water. Oh, sorry, let me move this into the screen. So I have less water in my cup. Pretty soon I'll have no water in my cup, right? But it definitely isn't going to be the same as adding two together, right? I can stir this all up, and eventually it will settle. The sand will go to the bottom, but I've put the two together. I haven't lost any water, food coloring, or sand, right? So let me show you another example under the camera here. Let me move this over so I don't spill it on my computer. All right. So let me give you an example of a model. A model is just a way to represent something so that you can see things change. So if I have two nuts, a jack, and a paper clip, and a penny. Let's say that these all represent different chemicals, okay? So if they all represent different chemicals, then if I mix them all up, I give them a chemical reaction, I mix them all up, and here's what happens. They're kind of all touching each other now, but do we still have the same amount of objects in the mixture? We do. And this is what happens in a chemical reaction. We have the same objects, they're just rearranged in a different way. So let me look at this with you one more way. When I talked about chemical equation earlier, we were looking at, you're going to look at something like this. Let me grab a highlighter here so you can see. So if we do an experiment, on one side, this is kind of like a math problem, right? Like on one side you have the reactants, and on the other side you have the product. So the reactants are what you put into a chemical reaction. So this particular thing, this particular formula says the reactants are magnesium and oxygen. So magnesium and oxygen are both different elements, and if you add them together, see there's like this plus sign right here? It's kind of like a math problem. If you add magnesium and oxygen, and then you give it a little bit of energy, then you get something on the other side called magnesium oxide. So the law of conservation of mass really says that whatever you do on this side, whatever you put together, will appear on the other side in the same amount, okay? So if we look right here, they're saying that we have 12.2 grams of magnesium and 8.0 grams of oxygen. See this? Magnesium, oxygen, okay? After we put energy in, when we get magnesium oxide, how many grams will we have? Well, all you have to do is you have to add 12.2 plus 8.0, right? You add these two numbers together, and you get 20.2 grams of magnesium oxide, okay? Let's do that again, but let's see if we can do it with a little bit bigger numbers. Feel free to use your calculator if you want, okay? So in this experiment, the reactants are magnesium and oxygen again, so we have magnesium and oxygen. When you add energy, you get magnesium oxide and a little bit of oxygen. So what they do is we have to rearrange the numbers. You have 48.6 grams of magnesium, 50 grams of oxygen. If you add that together, you get 98.6 grams total on this side of the equation, right? And so if you know that you have 80.6 grams of magnesium oxide, how many grams do you have of oxygen on this side? Well, you have to find the difference between 80.6 and 98.6. And the difference is 18, correct? Yeah, 18 grams. So you have the same amount here, 98.6, here that you have here, okay? So if we look at, and these are chemical equations, okay? So you have, whatever you put into it, you get out. So it's kind of like a math problem. If I decide to do, let me grab a bigger pen here. If I decide to do a math problem and I do 2 plus 2, it equals 4, right? So I have 2 of this, and I have 4 on the other side, right? They look a little bit different, but it's still the same amount on either side of my equal sign, okay? So that's kind of what the law of conservation of mass says. You can't have more or less matter on either side of an equation. You still have the same amount. It just comes up in a different form. All right, today, here's what you're going to do. You are going to finish your notebook, okay? You're going to finish your notebook, page 43. Well, I would say start it. And then you're going to watch a video and you're going to watch a tutorial. After the tutorial, you're going to take a screenshot of the certificate. And then you're going to watch a really short, or read a really short, brief piece about conservation of mass. And by then, you should be able to understand the law of conservation of mass and complete your notebook page. This is the last lesson for this unit. So when you're done, you're going to start your study guide. You just make a copy of the document, write the answers on a lined piece of paper if you want, any way you want. Go ahead and do it. And then you are going to complete a Quizlet, and you'll take a screenshot of your score that way. Make sure you take it as a test and multiple choice. So you're submitting both the Quizlet screenshot and your screenshot of your certificate today. But it will be on the same Google Doc, so make sure you have both screenshots before you finish up and submit. All right. Our next class period, we'll go over our study guide and we will take the test. Have a great day today. Enjoy the videos. You're going to learn something super scientific. And you're a scientist, so you'll probably understand it.